I see the challenges with people not necessarily thinking about how does storage play into that? How does management of storage, how does management of memory and new memory technologies play into the gzip, which is a heavier compression in your x86 processor? You might get a few megabytes per second of throughput, or in the newer server processor classes, maybe it's tens of megabytes per second. That is the data pipeline that from the origination of the data to putting it in storage, to moving it through memory, to moving it to the processor, whether that's a GPU for AI or a general purpose processor for different functions, and then back through memory, back to storage, or even through networking. We focus on improving that pipeline in the storage and memory domain.
Hi everyone, and welcome back to another episode of the Project Flux podcast. Today we're going to get a little bit technical. We're going to go into something that we haven't discussed before, all around storage. And with us is JB Baker, who is the Vice President of Marketing and Product Management at ScaleFlux. Afternoon, morning, wherever you are, JB, thank you for joining us.
Morning here, yes, thank you.
Yeah, I wish I had the day again. It's been one of those frazzle day today, so at least you're starting off fresh. It's good to see. So we have Yoshi with us as well as usual. And Yoshi's probably going to go in with some of the initial questions, JB, if that's okay. But just to start with, we always like to ask our guests, where's your mind right now? What's kind of the thing that's keeping you up at night, or the thing that you're thinking about quite a lot, either in the AI storage space or anything else, to be honest?
Yeah, it's really, aside from my immediate deliverables, in terms of for our technology and the market, it really is about how do we best align how our products work and how they deliver the data to the GPUs so that our users can get the most efficiency out of their total infrastructure. Because those GPUs are pretty pricey, right?
Yeah.
And they consume a lot of power. So we want to make sure that people are able to get work done with the energy and the dollars they put into their AI infra. And we're that small component that is kind of crucial on the back end, or maybe it's the oil in the works to keep things running smoothly.
Makes sense. So are you saying that with these GPUs, sometimes the way people are going around storage, it's not always the most efficient, and that ScaleFlux is a way of making it more efficient?
Yeah, I mean, one of the core things that we, even pre-AI, the way we went about designing the drives and the controllers in the drives, we design our own chips that are the controller that sits in that flash, the SSDs, these little things that plug into your servers. We integrated additional features and technology into our controllers to make the drives operate better in terms of how much performance you get per watt, how much data you can store per gigabyte, how much of the storage that's there you can use without slowing things down. Because typically as you fill up your drives, they slow down, and that slows down your whole server and your AI and everything. So people intentionally don't fill the drives, and that wastes space, it wastes money. And so our technology allows you to fill those drives and not worry about losing that performance.
Cool.
And JB, this is a growing challenge that we have now across the globe. We're trying to grow and increase the infrastructure that we actually have. So from your perspective, what is the challenge you're actually solving at ScaleFlux?
There's kind of two aspects of it. We're really solving the flow of data to from storage and to from memory into the GPUs. So that is, I refer to that as the data pipeline, that from the origination of the data to putting it in storage, to moving it through memory, to moving it to the processor, whether that's a GPU for AI or a general purpose processor for different functions, and then back through memory, back to storage, or even through networking. We focus on improving that pipeline in the storage and memory domain.
And so for those people who aren't that savvy with AI, why is this important?
I'm going to go a little deep here. Processors, and particularly GPUs, have grown exponentially in their ability to churn through data, right? Memory and storage have also grown exponentially in their ability to deliver data. However, the coefficient on that exponent has been a lot higher on the CPUs. So what we see is this gap growing over the past 10, 20 years in how much data a processor can handle per second and how much data the memory or the storage can deliver. And so what happens is you're choking those processors.
It's like a bottleneck, is it?
Yeah. I mean, we call it it's referred to in the industry as the memory wall. That memory is now blocking your ability to scale your processing performance.
That's interesting.
Yeah. And an analogy that I've kind of used is, imagine that your processors are the fertile field for, you're a farmer and you're out there planting your crops. Your processors are your field and you have seeded them. Mm-hmm. You have a giant lake full of water. That's all your data, right? And you have plenty of it. But the only thing you have to water that entire field is a little sprinkler can.
Yeah, okay.
Your crops are going to die. Your field is going to lie fallow. You're not going to get the productivity out of that field unless you fix the pipeline and you've got good irrigation running from the lake to the field.
Yeah. So to meet the aspirations of AI and everything that we're talking about, this kind of run to AGI, we've got to do something about it. Otherwise, like you say, you're just not going to. Is that? Do you see that as a wall or a barrier towards the AI, the path to AGI?
Yeah, AGI. It's going to have that. Getting data from the processor is definitely going to be a core challenge there, whether it's AGI or the other aspects of AI. And so what we saw kind of as AI really burgeoned over the last couple of years is that being able to cluster many GPUs together created real challenges for memory and networking first and foremost. And as they started to play whack-a-mole and iron out some of those challenges, now storage emerges as that next bottleneck. And also memory, just there wasn't enough capacity there to have all of these data sets or all of the data that's coming in to manage these larger models. I mentioned the exponential growth in the ability to churn through data and the ability to deliver data. There's also been this exponential growth in two vectors on the data sets that are used for AI. So one is how big the data is, how many gigabytes or terabytes or petabytes you're using. That has been growing exponentially. And then there's also the parameter count, where that's how many different ways you're looking at the data once you pull it all in. And that's been growing exponentially as well. So you have recently I found a chart that had the XY axis, and they were both on log scales for those two vectors. And I'm thinking about it, like, it just doesn't pop off the page because it looks like this nice, smooth, straight line.
Yeah,
but really what it is
reality.
That three-dimensional rocket ship taking out of the paper.
Yeah, well, that's a good way to describe what's happening with AI right now, I guess. Just sort of boiling it back a bit. So when we talk about storage, like I think, storage is often overlooked in the AI conversation, which I thought it was so important to get you on to talk about it. But what is computational storage? Most people listening to this podcast will know about storage, about like the SSD card that they put in the back of their computers. What's the difference between that and what you provide?
So computational storage, I won't go into the history of how it got kind of overburdened in its terminology, but the whole concept there is to say, can we make the data pipeline and storage in particular more efficient by moving some tasks out of the central processor, whether that's a CISC or a GPU, and distributing it down closer to where the data lives. Mm-hmm. And so we've got, whether that's computational storage or computational memory or near data compute might be more of an umbrella term for this. And there's a lot of different ways you could go about that. But what we've done is try to make something that's very broadly applicable with integrating hardware-based data compression and decompression engines directly into the controller in the drive. Typically, data compression has been around for decades, right? There's always been this challenge of, let me compress my data to save space on the drives. So on your personal computers, you probably gzip things, and you can't, for enterprise, you can't lose any of the data like you might on some of the audio or video compression codecs, where they might step down and throw away some bits to save space. We can't do that in the enterprise space, right? All of the data is critical. So it's got to be lossless compression.
Got it.
Doing compression in a CPU is extremely inefficient.
Why is that?
There's a lot of interrupts and a lot of just
Got
little
it.
grab data points, and you have to go things in and out of memory quite a bit. And so, like if you run a gzip, which is a heavier compression in your x86 processor, you might get a few megabytes per second of throughput. Or in the newer server processor classes, maybe it's tens of megabytes per second. That same function can be done in a hardware state machine extremely efficiently, because you don't have to worry about interrupts. It's a standardized process, so you don't need the capability of a general purpose processor. You can tune this down into a very specific set of circuits that are just hammering through this. So we can get terabytes per second of throughput many gigabytes per second of throughput in terms of with a hardware state machine within the drive itself.
And just on that then, JB, so what are some of the challenges you're facing in building what you're building at ScaleFlux?
I think, well, the core challenge in deploying this technology was developing the software and firmware in the controller that can manage the variation in size of data that gets written out to the drives. Again, a little technical. Traditionally storage has a fixed block length. The data will be chunked into, say, 4 kilobyte sections and written in those very standardized bricks that go out there.
Yeah.
When we do data compression inline in the controller, we don't get that one single same sized Lego brick, right? We get, instead of the 3x2, we get a 3x2, we get a 1x2, we get a 2x2, right. We get all these different sizes. And so there's more challenge in the firmware to keep track of not just where that block was put, but how big that block was.
Got it.
So that was a challenging technology to develop and verify. And now I think probably the biggest thing is just letting people know that it's out there, reaching people and getting them to understand that they can take advantage of this.
Well, that's a really important point, because I would imagine there's a lot of people who won't even know that this option's available. So my question is, like, there'll be a lot of CEOs or CIOs of companies listening to this, particularly in the space that we work in, which is project delivery. If they're looking right now to upgrade their AI infrastructure, what's the biggest mistake that you've seen people make, and how can they avoid that?
I think I don't have a lot of depth on that, but what I've seen a bit of and heard as I talk to customers is this, let's just go buy a bunch of GPUs. One system
like Elon Musk, just build the gigafactory or whatever it's called.
Yeah. One of the system vendors I was talking to is like, hey, my customers just came in and they're like, we need the GPU cluster and let's get a hold of the GPUs and let's put all our money there. And they don't think about the storage. They don't think about all of the ancillary pieces that go together to enable them to take advantage of those expensive GPUs and high bandwidth memory that they purchased, because there is networking, there is storage, not just in the speed, but also the capacity of the storage for all the data that they're going to deal with. Because one of the things that I think it was Microsoft highlighted this in a keynote or in a presentation at the Open Compute function last year, that AI is different from other workloads in that other workloads, let's say you do data analytics, you're doing a database query, there's a lot of data there that it has to churn through, but the process doesn't really create a lot more data. With AI, you pull in all this data, you churn through it, and you may spit out more data that has to be stored than what you brought in. So you have this, it's creating more data in addition to using a lot of data. And that's something that I think a lot of people don't necessarily think of as they start their journey into building out their info.
Yeah, which is why I suppose the latest models from OpenAI and what have you, they're having to charge such a lot of money for, because of the storage, because of the amount that they're having to produce every time someone does a query on it, it's producing a whole extra amount of storage that has to be stored somewhere.
That's probably an aspect of it. One thing with the LLMs, large language model queries versus, say, your traditional Google search as well, is they are going through their entire model and pinging a bunch of GPUs and looking at all of this data to then generate a response for you that's reasoned through. Whereas Google is just grabbing, these are the sites that are going to tell you what you want.
Yeah. Yeah.
And so a chat GPT query can take 10 times the energy, the kilowatts that a traditional Google search can burn too. So there's the infra is more expensive, the power is higher.
Yeah, that's really
there was a big investment up front too.
Yeah.
I also
And I think
there was that one generation of one AI image is similar to charging your smartphone.
Yeah, I think I saw that one too. Yeah.
Is it that much? Wow. Okay.
Yeah.
I think people, going back to the Google analogy, is quite interesting because understanding that technicality that you've just explained so well, JB, I think would help people understand why, because we've seen a lot of people not use these generative models in the way that they're intended. They treat them as Google, and then they wonder why they don't get great results. Well, we've trained ourselves, I suppose, almost over the last 20 years to ask Google questions in a specific way because of those barriers that you just talked about. But we don't have those barriers anymore, but people still insist on treating ChatGPT like Google. Do you notice that at all, or is that just in our industry?
I've noticed it just personally as I started using GPT. I asked very simple questions, and then the answer you get is kind of like meh. It doesn't really help you very much.
Yeah.
So there is definitely a lot to learn in the query engineering. What do you put in there? How do you, because you can write a paragraph long explanation of what it is you're looking to do, what type of data to include, what type of data to exclude. But there's also the LLMs definitely can give you wrong answers.
Oh, we've seen that. Yeah, the hallucinations.
I have had arguments with GPT over some things because it's like, I know that's wrong. I know you're doing the math wrong. Oh yeah, sorry. I'll do it the right way now.
But it's getting better, right? It seems that the kind of tendency to hallucinate seems to, with every new model that comes out, seems to be getting slightly better, which is interesting. Yeah. But knowing what I think, the reason why we do this podcast, JB, is for people, is to help people demystify what's happening out there, because it's moving at such a pace, and I see people just getting absolutely overwhelmed with the information. They almost shut down, and we don't want people to do that because this is a huge opportunity. But understanding the technicalities that go behind it is really important. So knowing what being in the space of storage, is there anything you do differently, do you think, knowing how the underlying mechanics work that maybe somebody who isn't in the tech space wouldn't do or wouldn't know?
I think in terms as a just user of
just as a user,
models, I don't know that I do anything differently. I may have spent more time just kind of understanding what they're doing. But no, I don't think I do anything necessarily differently. I just make sure that I double check what they provide me. And if you're doing research, you can get links that don't work. And if you don't ask your questions properly, it will make up things. And I've had to ask Mike, hey, are those real statistics? Oh no, those were theoretical examples. Would you like real data yet? So, but being in the industry, it's just, I kind of understand the folks that are trying to deploy the AI as opposed to necessarily the end user who's querying the data. I see the challenges with people not necessarily thinking about how does storage play into that? How does management of storage, how does management of memory and new memory technologies play into getting the most out of my AI infra?
And what you do at ScaleFlux is, you're improving the throughput, you're reducing the latency, you're making things a lot more efficient to run. And that is also something that we're trying to do with AI at the moment, with AI infrastructure, right? So I guess, knowing what you know about how energy intensive some of these prompts can be, do you feel yourself to be a bit more careful with how you prompt though? Because in your blog, for instance, you wrote about, I think it was Project Stargate, and that needing to balance rapid AI innovation with building sustainably. So what you're doing at ScaleFlux is also synonymous with what we're trying to achieve with AI infrastructure. So can you speak more about that balance between innovation and actually serving AI capabilities, but then also balancing it with sustainability, both from what you do at ScaleFlux, but also in the grander scale of AI infrastructure?
Sure, that's a broad question. So if we did not, as an industry, did not do things to improve the efficiency of the hardware, the software, the storage, the cooling, and even the facilities themselves, there is no way that we would be able to meet the demands for compute that are out there. And let me carve that up a little bit. So at the global level, data centers are already around 2% of global power consumption. And over the past 4 years, we added, just for data center consumption, the entire country of France. The equivalent of the entire country of France was added to the global grid over the
That's
last
insane.
4
Really,
years.
that much? That's
Yeah,
mad.
I think it's around 400 terawatt hours per year. So there's the global challenge, and then the data center. Aside from data centers, global power consumption, electrical consumption grows only at about 1% to 2% per year, because we find efficiencies in, like, our homes, the switch to LED lights from the old incandescent ones. It's not that we have fewer light bulbs burning; they're just a lot more efficient. So that's the example there outside of the industry. But the data centers are growing at 12 to 16% per year in the demand. So that's, you're looking at 6 to 8x the growth in that sector versus other sectors. And there are definitely chunks of the economy, regional hotspots, not pun intended, but truly hotspots like Ireland and Northern Virginia, where data centers already consume over 20% of the total electrical generation in those regions.
Did you say Ireland?
Yes.
As one of those. Wow, I didn't realize that. 20% of the global, of their energy.
20% of the local power generation goes to data.
That's
And
insane.
this is why we're seeing some of the hyperscalers like Meta, Amazon, Microsoft, Google, trying to, I guess, co-locate, in terms of where the data centers are run, but also linking it to renewable energy, but also teaming up with renewable energy sources to actually scale that. So, for instance, Sam Altman has his investments into the nuclear fission company, and I've forgotten the other one. I think it's solar. I've forgotten the name of it.
He's spreading his bets, isn't he, really?
Yeah, and is that the reason why then? Because they understand there's a need for this stuff, but doing it sustainably might be difficult, and it might be hard to reach the dream that we're all dreaming of, right? Which is be able to, I guess, step closer to AGI.
Yeah, I mean, if you put it onto the local utilities, then they're not going to keep up. There's already, like, Dominion in Northern Virginia and APS down in Arizona and others. They've already said, we can't bring on new power generation capacity as fast as you guys on your data centers want to scale. So those data center projects are getting delayed. Now with the Project Stargate and with Microsoft with bringing back one of the reactors on 3 Mile Island, etc., they are starting to say, hey, with my data center build out plan, I am planning for adjacent or co-located power plants, which comes with a lot of regulatory issues, right? You've got,
of course, yeah,
the NIMBY, the not in my backyard, for people who don't want some of that stuff built near their neighborhood. And small nuclear reactors are one of the things that's under investigation, and those will probably get deployed. There's going to be fossil fuels, there's going to be solar, there's going to be geothermal, there's going to be wind. I don't see that I think they all have to play together, right? There's not one panacea of this is the one way we're going to provide energy.
Well, to meet that demand, it's going to have to be, isn't it? Because I understand that, by 2028, the energy consumption is going to go up even more. I mean, you can see this growing exponentially. But there must come a point where it will just become, such a burden on sustainability. And the great kind of counter argument that we hear from a lot of people is we've got to invest in this now, even though we take a short-term kind of hit on the amount of energy we're consuming, because the promise of AGI and artificial intelligence is they'll be able to solve some of these problems, some of these big problems about nuclear fusion, et cetera, that will help us get over that. I mean, but it's quite a big bet, isn't it?
Yeah. I mean, that is true. That the source of our current problem or growth in the energy consumption may be the way to solve the way to get the energy more efficiently and even the processes themselves more efficiently. The data centers absolutely have to get more efficient to help
Mm,
mitigate this demand, and that's where we see the liquid cooling and the even the immersion cooling, because those
mm,
are one, they're significantly more efficient than air cooling with all those
yeah.
fans that
Are
you're
these
running at.
the ones that are literally in the sea or they're in a body of water?
No, that's something that's an entire the undersea data centers. That's something different from immersion
Okay,
cooling
okay.
that I'm mentioning here. No, so traditionally we had fans like your laptop and your desktop at home has a little fan that you can hear it kind of crank up and down depending upon what you're doing with your system, or if you're a gamer, you had your GPU card and it had its own dedicated fan and it would be cranking out like crazy when you
Mm,
were hammering through some high graphics game. But same thing in the data centers, right? They had fans pushing air across or pulling air across all of these components to cool them down, and hence the noise in the data centers, that whining turbine.
yeah.
But no, bringing liquid cooling directly to chips is more like having the radiator in your car,
Got
where
it. Okay.
there's it's all a contained system, and inside that chunk of metal that's attached to the processor, there is liquid that's getting heated up and then moved out to be cooled somewhere else.
Right. Okay.
And then immersion cooling is I'm taking my entire server and putting it into a non-conductive liquid. So there are these big vats of the
Right.
liquids, and they just dip the servers into those. And that is super efficient in terms of being able to move the heat that's generated by all the power consumption away from the processors.
There's still an issue, right, around water itself. So there's the issue that we don't have as much water. So I think it was, on average, I'm not sure what scale, but data centers themselves consume, was it half the amount of the UK's water annually to cool?
Wouldn't surprise me. I know there was some metric on number of cups of water that a certain process consumes that it wouldn't surprise me that it would be that high.
But bearing in mind we're an island here, it's kind of mad. I'm assuming you're talking about drinking water or
Yeah,
available water. Usually,
yeah.
that is crazy, absolutely crazy. But I mean, there's other promises, of course. There's also what we've heard a lot about recently: the breakthroughs in quantum computing.
Mhm.
Presumably, if that does, there was a big breakthrough from Microsoft last week, but you've got to take everything a little bit with a pinch of salt. But presumably, if quantum computing comes on, that reduces the load because more can be done with a chip, effectively.
Possibly.
Hmm.
That AI and quantum computing, I think, are currently a little bit orthogonal to each other. They'll
Hmm.
probably converge. But quantum computing will create additional problems. While it maybe makes that processor more efficient, one of the things that I've been watching a little bit is quantum safe encryption.
Yes.
So we all want our data protected,
Yeah, yeah.
right? And encryption today, whether it's 56-bit encryption to make sure that you can't just force break through the encryption in many years is one thing, but then once you introduce quantum computing and you change that vector for how fast they can churn through the options, now you need a way to encrypt data that can't be broken by quantum
Yeah.
computing. And what I have seen so far is that quantum safe encryption has not yet become a hard requirement, partially because of how compute intensive it is. So it's going to
Hmm.
consume a lot of power to now make your data safe.
Right. So it'll
So
give
there's
with one
going to be the
hand
push
and it will
pull.
take away with another.
Difference, yeah.
Yeah, yeah.
JB, so I saw, in terms of some of these alternative methods, and we looked at a story a while back now, about 6 months ago, and it was about a company called, I think, Final Spark, and they were growing brain organoids in a lab and then running AI compute off of those. Now, at the time, they said it was a
Okay.
lot more efficient, but these brain organoids were only living for about 100 days. But you could actually go onto the platform itself and then run some of your models off of it. So I don't know. I don't know if some of these alternative methods are something which would be in competition, or what's the potential behind some of these. But do you think there are other alternative solutions to what you guys at Hyperscale ScaleFlux are delivering? which might be outside the box or inside the box?
Well, let me answer two parts there. One, for what we at ScaleFlux deliver, we're delivering the storage and then memory controllers to help break down that memory wall and help you get more efficiency out of the AI processors. What you just mentioned of using totally breaking away from the traditional more transistors into smaller space and more parallel processing. Yeah, maybe some kind of organic computer is the future, because our brains are extremely energy efficient. Don't remember the exact number off the top of my head, but it's like our brains run on something like 7 watts. And then if you compare how much our brain consumes to do something versus an AI, we consume a lot less power, but we also can't do as many things in parallel.
Yeah.
Right.
Yeah.
But I think in terms of work per watt, our brains are very efficient.
Interesting. So what do you think? I mean, I know it's really difficult to predict even sort of 6 months into the future at the moment, let alone 5 years. But where do you think the AI infrastructure could look like in 5 years' time? And what perhaps could businesses be doing today to prepare themselves?
Yeah, I think one of the things that we end up doing is we over generalize AI infrastructure. At least for me, being in the data center focused, almost everything I see and read is more focused at that hyperscale level, the ChatGPT trainings, the Grok trainings, the Microsoft and Google, their AI trainings. And they're putting out these massive scale with hundreds or thousands of GPUs clustered together to solve problems. What we don't hear a lot about that necessarily, or doesn't get the bulk of the news, is we're going to see fragmentation, right? So we've already see it somewhat instead of there just being general purpose GPUs that are used for the AI processing, the Blackwells and all the NVIDIA processors, you will see specialized processors. So like Meta has already been public with this, of doing their own GPU that is large language model focused. And it's
I heard OpenAI as well was looking at that.
Yeah. And so these are optimized for their specific use case and the specific balance of memory versus data capacity for large language models. You're going to see edge AI processors that are more optimized for running inferencing. They're not creating the model is delivered to them. And then I need to recognize images and video and things like for self-driving vehicles. And so these edge AI processors are going to be optimized for different tasks than those data center processors. So what do people do to prepare? Make sure that you're looking at what it is you want to accomplish, what it is you're trying to do with your AI before you invest in doing in that infrastructure. So you make sure you buy the infrastructure that's going to be appropriate.
So do you think there's going to be like some, obviously NVIDIA's the big kind of hit over the last few years. So what you're saying, because it's going to be more kind of not democratized, but there's going to be different people coming out with very specific chips for specific purposes. Do you think there'll be other NVIDIA's that just go to the stratosphere all of a sudden out of nowhere?
Oh, there probably will be. So as big as NVIDIA, maybe not for a while.
Maybe not as big as NVIDIA. Yeah.
That one's going to be tough to catch up to. I look at NVIDIA now as the way Intel was probably 30 years ago, right? 20, 30 years ago, where it would just, they just dominated. They weren't necessarily, even back then, there were certainly specialized processors that were better at certain tasks or better for certain environments. But the Intel x86 architecture was just the beast, the 800-pound gorilla in the room. And now,
even with its flaws, right? Even with its flaws, I mean, from my understanding, it wasn't necessarily the best. It just became they had a monopoly on it. Yeah.
It was there were faster processors for different tasks, but Intel became a manufacturing machine and the architecture of choice. And so then all the software came onto it. NVIDIA has taken on that role in the industry. And they're doing, from what I see, and we'll see when you publish this, but when we're recording, next week is NVIDIA Global Technology Conference, right?
Yeah.
So we'll see more next week. But they're building out the whole ecosystem around it with the software and the tools to build out solutions for AI to use that processing capability. They are helping with the efficiency thing, not just in building more efficient processors, but also looking at, say, the whole rack level instead of just the little chip level of how do we optimize cooling and inter-chip connection and sharing memory and data at the whole rack level.
And JB, just because I've been looking at this in small amounts, but just considering the idea of decentralized AI or edge devices, federated learning systems, is that something that you're familiar with?
Not particularly, no.
But do you think, because in that instance, then you kind of lose the reliance on centralized AI systems like data centers, I guess. So I guess my interest would be is, would people be interested in that sort of type of processing?
You're talking about the smaller models, the small language models, and the
I guess we're running
on-device models
in a decentralized way.
Oh yeah, absolutely. You're going to have very more specialized models that will come out, and then that's going to change the structure for the processing. I mean, even the recent the news about DeepSeek recently, they structured their model differently from how OpenAI structures their model. The DeepSeek was this mixture of experts.
That's the one, yeah.
Where they have, they're training modules of this to be broken down on a smaller chunk set of data, like maybe you're training an expert as a lawyer, or even a family law versus a criminal law or something, so that you can contain the scope of data that you're putting in to train that expert. And then when you go and query that expert, you also don't have to hit the entire data set or all of the.
So it's more efficient.
Yeah. So depending on what your query is, it might just grab a handful of experts instead of bringing in, I don't know, Einstein or somebody that knows everything about everything.
Yeah.
Decentralized, yeah.
And nobody saw that coming. I mean, this is what I mean about the space at the moment, is we're trying to predict. I gave you the 5-year prediction. It's almost impossible, isn't it? Because there is just such movement. But just sort of coming towards the end of the episode now, JB, just want to sort of go into some kind of more questions about you, really. So beyond storage, where we talked a lot about storage, what's one other emerging technology that really excites you right now? Is there anything out there?
Yeah, well, I'll stay within the same domain, but memory.
Yeah.
So we talked about the memory wall, and storage helps with that, but we've got to find a way to shrink that gap between how much data we can get to the processor and how much it can consume. And the traditional architecture of attaching memory directly to the processor doesn't allow us to do that, right, as an industry. So there is a new technology. This is an industry consortium called CXL, Compute Express Link. So this is one technology where it allows us to attach memory onto a different bus, onto the PCIe bus, which is the same place where we attach network cards and storage devices. So instead of it having my memory capacity and bandwidth limited to how many lanes I can run directly off of the processor, I can now expand that out and provide that very high bandwidth memory backup or data flow back to the processors. And I can now allow sharing of this memory. So when we talk about clustering processors together to perform bigger tasks, there's a streamlined path for them to share the data across processors.
Okay.
I did steps 1 through 4, put it into memory, and then you grabbed that out of memory and did the next steps.
Wow. So it's getting rid of a bottleneck there, effectively, is it? It's almost like the analogy, I suppose, of getting rid of like a little country lane and giving it a motorway or freeway, as you guys call it. Yeah.
Putting the freeways in there instead of the one-ways.
Well, that's kind of a massive
in the
impact,
UK,
isn't it?
man, I drove there recently, and some of those roads.
Yeah, and you won't want to be on a road where I'm either. There's a running joke on this podcast about my driving, JP. So if you came here and you avoided me, that was always a good move.
Okay. I just the single lane in both direction, 50 mile an hour speed limit. There's the passing spot where you must pull over.
What could possibly go wrong with that? One last question then. What's the one thing you want listeners to take away from this conversation? If there was one thing you...
I'd say as you are, when you're doing AI, make sure that you have an objective plan for it. What is it you're trying to get out of this AI? And then make sure you look at the full series of impacts that you're going to have by deploying it. What is it going to do to memory? What is it going to do to networking? What is it going to do to storage? How am I going to share this data across here with my data orchestration to get the most out of it? And then you also have to look at the efficiency. I mean, you said your audience is a lot of the building out of the data centers themselves.
Yeah.
That level of infrastructure, I tend to focus on the servers and the chips infrastructure. But at the data center infrastructure level, it is that how are we designing this to have efficient cooling and energy efficiency and efficient power delivery into the racks? And for the immersion cooling, that requires different structural integrity to support the weight of these liquid vats that are coming in there.
Yeah.
So I know you can't retrofit a lot of existing data centers because they just can't support that weight.
Well, it's the future. That's what a lot of talk is about, future-proofing the data centers, because going back to what we were just saying before, things are going to change again with that. So you don't want to have a situation where you've got these data centers that you built and they're no longer usable because of whatever restriction. You've just mentioned the weight one, but it could be a million other things as well. So
weight, power has definitely become the bottleneck. I talk to a lot of customers. What is it that your problem is for your existing data centers? And it's, when I built out my however many tens of megawatt data center, that's all I'm ever going to have in there. I can't go and double the megawatts of power that's supplied to it, even though the power consumption density is doubling and quadrupling. So in order for those older data centers to put in new compute infrastructure, they're going to have a lot of empty space, right? Because when they built out and planned for however many thousands of square feet of floor space, well, the chips were only consuming 100 watts or 200 watts each. Now those processors are consuming 1,200 watts. So you can only fill 1/6 of your data center floor space before you've consumed all the power.
Wow, so many moving parts, aren't there? But we're going to have to draw it to a close there. I mean, it's been absolutely fascinating, JB, just to find out more about this. And I think it's important for everyone listening to Project Flux to know about, what's going on. There's some really good advice there from JB. Where can people find out more about ScaleFlux, JB?
Our homepage is perfect, scaleflux.com. And we've got a bunch of information there about our technology, the storage technology, the CXL technology, how we save power. And we work with a lot of partners to deliver this because, as I said, we build these little drives and the chips, and a lot of your users are going to buy systems. And so we work with system vendors to deliver everything.
Cool. And you've got a LinkedIn as well, so we'll put those on the show notes and the ScaleFlux website. So all we can say is thank you very much indeed for your time. It's been enlightening, and hopefully you'll come on again in the future when the next kind of big iteration happens and you can tell us what's happening in the computational storage world. Yeah. But until then, we'll say goodbye and thank you very much for your time.
All right. Bye. Appreciate the
Project Flux is here.
That's a wrap for today's episode. But before you go, exciting news. Project Flux is teaming up with Project Management Global to bring you the latest in AI-driven project delivery and essential management insights. Through this partnership, expect weekly AI insights, practical tools, and expert thought leadership, ensuring you stay ahead in the evolving project landscape. Stay tuned for exclusive content, joint research, and strategies to supercharge your project outcomes. You can learn more at www.pm-global.co.uk and be part of the future of project management. See you later.
Project Flux is here.
Just want to give a big shout out to our sponsors, Construct AI. For anyone interested in looking at Construct AI, the link's in our show notes. There's a free tier that you can play around with. Yoshi and I have been using it for a good year since it was originally launched, and we get a huge amount of value out of it. So I thoroughly encourage everyone to go onto the Construct AI site and have a play around.
Cool. And guys, before we sign off, please don't forget to share, follow, and like all of our stuff. So that helps us to engage with you and understand a bit more about what you want so we can bring it to your doorstep as early as possible.
See you later, everyone.